Hello and welcome to Foundations in Pre-Cal 10. We're going to take a look at using trig ratios to find side lengths. So we've already gone through and derived the trig formulas. So we know that sine of theta is opposite over hypotenuse, cos is adjacent over hypotenuse, tangent is opposite over adjacent, and sometimes we use the acronym SOHCAHTOA to help us to remember those formulas because sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So we've practiced with naming the side lengths appropriately. So now we're going to put those trig ratios to use. So the way that I go about doing these questions is the first thing that I do is I circle the angle that I'm talking about because I know that when I change the angle, I change the names of the sides. So circle that angle that we're talking about. And then you're going to name the sides. So the sides that either have a number on them or are the ones that we want to find. Okay, so to that 51 degrees, I know that this is opposite and this one is adjacent. So opposite and adjacent is the tangent ratio. So I write down the formula. Tangent of theta is opposite over adjacent. And then I substitute in. Remember that theta means angle. Okay, so it's a variable. You're putting in the value for the angle. So in this question, it's tan of 51 equals x over 15. Now I want to solve for x, so x is being divided by 15. So to undo that operation, I multiply by 15 on both sides of the equation. That will cancel away. So I punch into my calculator 15 times tan of 51. Now it's super important that you actually get your calculator out here and figure out how it works because some calculators you have to enter in the angle first and then the trig ratio. Some you put the trig ratio in and then the angle. If your calculator opens up a bracket when you put in tan, you have to make sure you close the bracket after the angle. So please make sure you get your calculator out and figure out how to enter in 15 times tan of 51 and get 18.5 meters. And if you can't figure that out, put your hand up now and ask me, or write it down and ask me when you get back to school. Okay, let's look at the second example. So again, I'm talking about 27 degrees. We're going to name those sides. So this side is the hypotenuse. This is the adjacent. It's next to. So that is the trig ratio of cosine. So cos of theta is adjacent over hypotenuse. Subbing in what I know, cos of 27 degrees is equal to 14 over x. So this one's a little bit trickier to solve for because the x is in the bottom of a fraction. So you need to get it up top before you can solve for it. So if you want, you could think of this as being over 1, and then we could cross multiply. And when I do that, I get x times cos of 27 equals 14, and then I will divide by cos of 27 on both sides. So 14 divided by cos of 27 gives me 15.7 yards. Let's look now at some word problems. So a couple of common things when we're dealing with trig ratios is angle of elevation and angle of depression. So basically, angle of elevation is just the angle that they're always measured from the horizontal, and when you look upward, it's the angle of elevation. Sometimes also called the angle of inclination. I'm just going to jot that down because sometimes we hear that one. Angle of inclination. It's the same thing. Angle of depression is when you are from the horizontal looking down. The thing that it's important to realize is that the angle of elevation looking upward is the same as the angle of depression looking downward. Okay, so if I call this theta elevation and theta depression, I know that theta elevation is equal to theta depression. Okay, that'll make your life a lot more simple later. And they are always measured from the horizontal. So let's look at a couple of examples. If your distance from the foot of a tower is 20 meters and the angle is 40 degrees, find the height of the tower. Now, there's no tricks here. You're always going to get a right angle. So if we have something tall, we're going to call that a tower. And I'm going to be standing over here. Okay, we create a right angled triangle. This is the tower. We want to figure out the height of the tower. I'll call it T. My distance from the tower, so if I'm standing over here, my distance is 20 meters away. And it says the angle of elevation is 40. So from the bottom looking up, it is 40 degrees. Okay, so then I figure out what trig ratio that is. So this is opposite and adjacent. So that's the tangent ratio. So tan of 40 equals opposite over adjacent. So I'm going to multiply by 20 on both sides. And I end up getting the tower is equal to 16.8 meters. Okay, the angle of depression from the top of a castle to the boat on the water is 25 degrees. If the boat is 50 meters from the base of the castle, how high is the castle? So same idea, if this is my castle and I've got a boat over here on the water, and I'm going to create a right angle triangle. The boat is 50 meters from the base of the castle. Okay, base means bottom. So this is 50 meters away. Now it says the angle of depression. Okay, angle of depression is 25. So technically, that means from here measured downward is 25 degrees. Now, I know that I have parallel lines, and within those parallel lines, these would be considered alternate interior angles, and alternate interior angles are equal. So that 25 comes down here into the bottom, right? Remember what I said? The angle of depression equals the angle of elevation. Okay, so those are always measured between the horizontal and the hypotenuse. And I want to calculate the height of the castle. I'm going to call it C. So which trig ratio? Again, name them to my 25 degrees. So this is opposite, this is adjacent. So that's going to be the tangent ratio. Tangent of 25 degrees is equal to opposite over adjacent. So times by 50 on both sides. And I end up with the castle being 23.3 meters tall. Now it is possible, just to backtrack here, that you might recognize that if this is 25 and this is a 90-degree angle, that inside of the triangle up here is 65 degrees. And then you would call this opposite and this adjacent. Totally fine. You can do it that way as well. Okay, so now I want you to move on to the practice question. There's quite a few just triangles where you're finding length. So maybe just start with, say, the odd numbered ones. And if you find that you're getting them all right, then you probably don't need to do the evens. But if you are struggling, then you might want to do more. But do the odd numbers with the triangles and do all of the word problems. And then you can move on to finding angles.